All right, so today we're actually going to do two sections in one. We're going to do section 3 and section 4 because they're both the same thing, okay? It's just in section 3, the problems or the technique is kind of like a guess and check method. And then in section 4, they give you a much more systematic approach. So I like systems, I like a recipe, I like directions. So I'm just going to show you just how to do this using section 4 techniques. So the key here, or the key difference in this section, is we are still factoring trinomials. That's still a thing. Except now, the number out in front of the x squared term is not 1. It's going to be something different. Okay? See, in section 2, you'd have a problem like this. X squared plus 5x plus 6. In other words, a equals 1. That's the coefficient out front. In our current section, 3 and 4, now you have a number out front. And that kind of changes things. Because in the previous section, if we were to factor x squared plus 5x plus 6, we would put our parentheses, put an x and an x, and not really worry about anything. However, in this section, how do you know the 3 is not in the second set of parentheses, or maybe the 3 could be in the first set of parentheses? All right, and I'm going to be honest with you, the fact that it's 3x squared is the easiest case. If this was, let's say, 12x squared plus 11x plus 6, you could have 1x, and 12x. Let me write this a little cleaner. You could have this. Okay, you could have this. You could have this. You can have this. And this. So 1, 2, 3, 4, 5, 6. You have 6 possibilities right off the start on how to arrange those numbers. So there is a way that we can do this so we can get rid of all the guessing. Because that's really what that is. It's guessing. All right? So the technique that we're going to use is called, let me zoom in. It's right here. It's called factor. Oh, I was going to say factor by grouping. That's step 4. It's called the AC method. Okay? It's called the AC method. Now, the steps are pretty much the same as previously. However, there's a couple additional things that you need to do. So I'm going to read the steps, and then I'm going to do the first problem while you watch. Then I'll let you write the first problem down. I'll say, go ahead, write it down. And then we'll do that again. All right? So step 1, you always want to factor a GCF provided it exists. All right? Now, 1A is extremely important. I'm going to put a star there. Because what you're going to want to do is you want to get an idea of what this answer is going to look like. Most importantly, in this step, it's all about the signs. It's all about, are both of my binomials, are they both pluses, are they both minuses, or are they a combination? Plus and minus. Okay? So that's step 1A. It's massively important. Step 2. This is where we start the AC method. So remember, we're looking at problems of the form ax squared plus bx plus c. So what we're going to do is we're going to multiply the coefficients a and c together, and we're going to find the factors for that result. Okay? Step 3, we're going to use the factors found in step 2, and we're going to rewrite our middle term. So that bx, we're going to rewrite it. And by doing that, we actually create a polynomial in 4 terms. So step 4 says, when you rewrite the middle term, factor by grouping. Okay? So I'm going to scroll up just a little bit. And I'm going to do this problem. Now, I'll do the first one. All I want you to do is just follow along. Don't even write it down yet. I'll give you a minute to write it down. It's not a lot of writing. But I just want you to see what's happening. Okay? All right, so step 1. I'm going to factor out a GCF if it exists. And if not, I'm going to get an idea of what my answer is going to look like. So I noticed there's no GCF. So now I'm going to get an idea. And what I mean by that is go ahead and place your signs. For example, and like I hope you're watching me right now, okay? Let me maximize this real quick. Sorry. It's annoying me. All right, there we go. Okay. So, if this 2 wasn't there, if I just scratched out that 2 and that was my problem, I know I would put x plus, I'd put an x here, and then the second sign would have to be a plus because I have positive 15 at the very end. So that's very similar to what we just did previously, okay? So all I'm going to do here is just erase those x's and just leave the plus signs in there. In other words, I know that is what my answer will eventually look like. He's over here. Here, go get mommy. Anyways, I know my answer is eventually going to look like that. Now, this is extremely important because in step 2 and 3, I need those signs. So you always, always, always want to write this out. So there's step 1. Step 2. We're going to multiply A times C. So in this situation, it's going to be 2 times 15, which equals 30. Okay? Now we're going to write out the factors of 30. So 1 and 30. 2 and 15, 3 and 10, 5 and 6. Now here's step 3. Step 3 says rewrite that middle term. All right? So I know my middle term is 11x. Now I'm going to rewrite it using the information from step 1 and step 2. Step 1 says no matter what pair of factors I pick, both of the numbers are positive. And step 2 says that positive 5 plus positive 6 equals 11. So 11x is going to equal 5x plus 6x. In other words, I'm rewriting that middle term. So now I'm taking a polynomial that was initially a trinomial, 2x squared plus 11x plus 15. And I'm rewriting it as 2x squared plus 5x plus 6x plus 15. So I took 11x and separated it. I broke it down. And that's what the AC method is all about. So now I factor by grouping. So I group the first set. I group the second set. Remember, never group the middle sign. I look for a GCF in the first set of parentheses. That's going to be an X. I look for a GCF in the second set of parentheses. That's going to be a 3. I know all of the work that I've just done, step 1, 2, 3, and all the way up to 4, is all correct. I know that. And how do I know that? Because I have a common binomial inside those parentheses. And I'm going to factor that out. And what's ever left over, the x plus 3, goes in the second set. And that is how you factor a trinomial of the form ax squared plus bx plus c using the AC method. Does that make sense, everyone? So go ahead and write this down. And while you're writing it down, I'm just going to kind of talk over you a little bit. The key to this is breaking up that middle term, that bx. In order for us to successfully do that, we need to know A, or how about 1, what are our signs in the binomials? And then 2, what are the 2 factors that when I combine them, it gives me that middle term? So by doing that, I can break up the middle term into something with 4 terms and then factor by grouping. You can do this method on every single trinomial problem that we're going to encounter. You could do it for every single one. Okay, are there any questions? All right, I'll wait. You can write it down. I'll go ahead and do step 2 when we're ready. Or I mean number 2, not step 2. I still got to get the cobwebs out. I woke up really late today. I woke up at 7:40. Okay, we ready? All right, I'm going to scroll up. All right, so the next one, 15x squared minus 22x plus 8. So I'm going to just speed up a little bit more now, okay? Not too much. Step 1, look for that GCF and get your idea of signs. There is no GCF. I copy the first sign down, and I know a negative times a negative equals a positive, because I want that positive 8 at the very end. Okay? So there's step 1. Step 2, we're going to take 15 times 8. All right, and that's going to equal, if my math serves me correctly, I'm going to get out my calculator just to make sure here, because I think it's 170. But I'll make sure. 15 times 8. And I was wrong. It's 120. All right, now we need all the factors of 120. Now 120 is a very large number. So here's an easy way to do this, okay? Watch this. I'm going to write 1 through 10 in a column. And then all I'm going to do is I'm going to use a calculator if I need to. And I'm going to find those factors. I know 1 times 120 is 120. I know 2 times 60 is 120. I know 3 times 40 is 120. I know 4 times 30 is 120. Okay. 5. I forget what 5 is. So what I'll do is I'll take 120 and divide it by 5. So that's going to be 24. So 5 times 24 is 120. 6 times 20 is 120. Now, I'm pretty sure 7 doesn't work, so let's check it. Okay, so you see how we got that decimal 17 point whatever? So 7 I just scratch out. I know 8 and 15 works. Okay. 120 divided by 9, I don't think that works. Yep. And 10 times 12. Now, if you need to, you can keep going, but watch what happens. I know 11 is not going to work. The next number would be 12, but notice here and here I start repeating myself. So initially I had 10 times 12, now I have 12 times 10. Once you start to see yourself repeating, you could just stop. Okay, now, step 2, we're not done with it yet. We got to find those 2 factors. They're both negative. That's the information from step 1. And those 2 factors have to combine to give me negative 22. That's going to occur all the way down here at the bottom. Okay, That occurs all the way down at the bottom. Does that make sense so far, everybody? Okay. Step 3. Negative 22x equals negative 10x minus 12x. Now, it doesn't matter if you wrote negative 12x minus 10x. That doesn't matter. The order doesn't matter just as long as you get the signs correct. Okay? Now, step 4. Let's go ahead. Let's rewrite this and then factor by grouping. 15x squared minus 10x minus 12x plus 8. Now, we do have to be careful because when we create our groupings, 15x squared minus 10x, notice we have that minus sign in the middle, which means I'm going to get 12x minus 8. That second sign has to change. Okay? So now in the first grouping, let's figure out our GCF. That's going to be a 5x. So that's going to give me 3x minus 2. In the second grouping, I can factor out a 4. And that's also going to give me 3x minus 2. And I'm so happy right now. It's Friday. I'm with one of my favorite classes. And I have common binomials in this problem. That's why I'm so happy, because I know all the work I've done wasn't for nothing. So I factor out the 3x minus 2. And I rewrite this as 3x minus 2 times 5x minus 4. And that's how you factor this. Any questions so far? None whatsoever. So I could give you a test or a little quiz on this right now, and you'd be fine. Courtney, what are you drinking? What was that? Coffee, tea, water?
It's coffee. Every morning, coffee. I got up at 7:42.
Oh, did you?
So, yes.
Oh. Yeah, I woke up.
I drink coffee. You don't, so.
No, I woke up and Ernie was late. He lays in bed with me. He's like just staring at me. And I can hear Molly getting ready. And I'm like, where's the dog? And I look over and he's in the other room. He's just laying down on his little blanket. He has a little blanket now. Did you guys ever see his blanket? Yeah, he has a little blanket. Ugh. Pour on your blanket. See? It's a nice little throw rug and it says Arthur. It says Arthur. And he loves it. He drags it all around the house. And then when he's ready, he'll drag it and then he'll just put it somewhere. And then with his nose and his paws, he makes like a little bed, then he falls in it. It's really cute. So, go ahead. Do 3. I'm not going to do it. You are. I will give you, since nobody had any questions, it's 8:20. I'll give you till 8:23. Should take you 3 minutes. All right. So did anybody happen to get an answer? What is the final factored form? Anybody?
I got open parenthesis 4x minus 1, close parenthesis, open parenthesis 2x minus 5, close parenthesis.
Okay. All right. All right. All right. All right. Let's see if you're right. That sunlight bothering you?
Yeah, it's getting a little bright. It was like 5 at first, and now it's like getting in my eye. But I don't want it to get all dark, and then I have to click a light on.
Oh, I feel you. I feel you.
I like the nice sunlight, but it's like too much.
I'm with you on that. So let's go ahead. Let's do this. Step 1. No GCF. Let's get an idea of the signs. Minus, minus. Perfect. No. Minus, plus. No, I was right. Minus, minus. My bad. Step 2. We're going to take 8 times 5, which is 40. We're going to write out the factors. 1 and 40. 2 and 20. I know 3 doesn't work. 4 and 10. 5 and 8. And I think that's it. I think that's it, right? So now I know they're both negative, and they both have to combine to give me negative 22. It's going to happen right here. So step 3. We're going to take negative 22x, and we're going to rewrite it as negative 2x minus 22. Step 4. Let's rewrite the polynomial using our new middle term. So we get 8x squared minus 2x minus 22x. Sorry, wrong number. I wrote minus 22x. It should have been minus 20x. That is the one mistake I make all the time. So I'm looking at the wrong thing. So we get 8x squared minus 2x minus 20x plus 5. Factor by grouping. 8x squared minus 2x minus 20x minus 5. Remember, that middle sign is negative. So when you do your grouping, the second symbol has to change. Now, for my first GCF, factor out a 2x to give me 4x minus 1. And for the second grouping, I can factor out that 5 to give me 4x minus 1. Now I have a common binomial. I know I'm right. Factor the common binomial out. 4x minus 1. 2x minus 5 is left over. Perfect. Excellent job. Are there any questions? You'll notice when you do this, it'll get easier. Especially if you're not trying to teach it and talking out loud. Then you'll be able to do it very quickly. Okay, let's do the next one. Now, this next one may look very difficult, but it's not. It's actually very simple. Okay? You got 10x squared minus 13xy minus 3y squared. This is really the first time out of all of our factoring where we've had this squared term up front and we have a squared term at the very end. But that doesn't matter for us. Our technique is all that we need to know. If you know your technique, I don't care what the problem looks like, you can do this, you could do it. All right? So let's do this one together. Now, let's write together. So step 1, there's no GCF, but I will get an idea of what my signs will look like. So I know my final answer is going to look like minus and a plus. Okay? Step 2. We're going to take 10 times 3. And that's going to be 30. We're going to write out the factors of 30. 1 and 30. 2 and 15. 3 and 10. 5 and 6. Okay? Now, we need a pair of numbers that combine to give me negative 13, and I know one of those numbers is positive and the other number is negative. The only way you can get negative 13 with a pair of numbers that we have is right here. Positive 2 minus 15 is negative 13. So I'm going to go ahead, step 3. Let's rewrite this. Now, here is where you got to be careful. So watch me. 13xy, that's its name. Actually, technically, it's negative 13xy. That is going to equal 2xy minus 15xy. Okay? So make sure that you are writing xy because that middle term is negative 13xy. So make sure you're writing that. Now, here's the best part about this problem. We have options. Because remember, I said this in the previous one. It doesn't matter the order in which you write these, just as long as you get the signs correct. So I can have 2xy minus 15xy or negative 15xy plus 2xy. Which one do you think I'm going to pick? So when I go into step 4, I'm going to be more specific. When I go into step 4 and I start to rewrite this, am I going to pick the first set or the second set? Which one do you think I would pick?
The first one?
I would not pick the first one. Would you like me to show you why?
Yeah.
All right, so do not write this down, everybody. Just watch. Just watch. If I pick the first one, then when I go to factor by grouping, and I'm writing very quickly here, I notice that I have that minus sign. So I'd have to change that second sign, correct? And that's a potential error for me. Like I might forget to do that. If I do the second one, notice now when I go to group, I have a plus sign in between. So I don't have to worry about changing signs. Does that make sense? Both are 100% correct. You can use either. I'm going to pick this one only because I don't want to worry about changing signs. So that is a little, I don't know, little piece of advice, a little nugget of advice. If you could make the second number positive, make it positive so you don't have to worry. So, step 4. Let's rewrite 10x squared minus 15xy plus 2xy minus 3y squared. So now I'm going to find my little GCF. Let's see, for the first one, it's going to be, I think, a 5x. So that's going to give me 2x minus y. For my second grouping, I could factor out a y. That's going to give me 2x minus 3y. I'm feeling really confident about myself because my common binomial is there. Actually, hold on. I forgot to write my 3. I saw Courtney looking at me like I was crazy. All right, so now I'm going to factor out the 2x minus 3y. To give me 2x minus 3y, or April, here's like a little key. Instead of saying like open parentheses, close parentheses, which is still fine, but it's a lot of words. The quantity of 2x minus 3y multiplied by the quantity of 5x plus y. Okay? How are we looking, everyone? Pretty good? This isn't hard. It's just taking your time. Slow yourself down. Follow the steps. I'm recording the lecture. It'll be uploaded today. If you go through your homework with this problem or this problem as a model to help you walk your way through it, talk to yourself out loud, understand the steps, you'll get every single problem right. Because remember, it's not the problem that I'm concerned with. It's the technique. Okay? For the last two problems, excuse me, there's going to be a GCF. After we do the GCF, everything else is the exact same. All right, so let's do 5. Step 1. So I definitely have a GCF here. 24x to the 4th plus 40x to the 3rd plus 6x squared. Okay? So I'm thinking I could factor 2x squared out. Is that what you guys think? 2x squared? So that's going to give me what? 12x squared plus 20x plus 3. Okay? Now, directly underneath, I'm going to get that idea. Boy, I really picked some easy problems. Because our idea is, we know it's going to look like this. Our final result is going to have a 2x squared out front, and then the two binomials are both going to be positive in the middle. Step 2. We're going to take a times c. Now, I'm looking inside the parentheses. So it's going to be 12 times 3, which is terrible math. 36. I put 15 there. Like, it's Friday. I'm going to use that excuse. It's Friday. Hey, at least I was quick enough to notice it was a mistake, right? So 12 times 3 is 36. Let's go ahead. Let's write the factors. 1 and 36. 2 and 18. 3 and 12. 4 and 9. And 6 and 6. Now, I know I need the pair of numbers. They're both positive from step 1 that will combine to give me plus 20x. That's going to happen right here. Okay, I guess my keyboard's not on, so we're just going to have to deal with it. All right, so here's step 3. Excuse me. 20x equals 2x plus 18x. And now I'm going to rewrite the entire problem. And just be careful. That's it. Remember, the 2x squared that you factored out comes along for the ride. Then you're going to rewrite the inside. 12x squared plus 2x plus 18x plus 3. Now you're going to factor by grouping. So 2x squared equals, and I'm going to write a bracket because I don't want too many parentheses in here. So I do my groupings. And like I said, the only reason why I use the bracket is so I can visually see the difference. All right, so for the first set, let's see here. I can factor out a 2x. So that's going to give me 6x plus 1. For my second grouping, I could factor 3 out. That's also going to give me 6x plus 1. I'm excited. Common binomial. For a final answer, 2x squared times the common binomial, 6x plus 1, times 2x plus 3. And there's your final result. So the only new thing in this problem, there was a GCF at the very start. That was it. There's nothing too crazy. All right. How about you do number 6 for me? Now, number 6, there is a GCF, so be careful. Just don't dive straight in. Okay, are we ready? Still need some more time? I'm sorry. Oh, no. Oh, no. Dude. Oh. You chewed up Krillin's head. It's a dead Funko Pop. Already killed it. Hey, at least you didn't kill Master Roshi.
My dog chews up everything, so I understand.
Oh, yeah. But it was my fault. I wasn't paying attention. Okay, are we ready? All right, so I'm going to speed up. Step 1. GCF, definitely an X. All right. Now, everything from here is just simple. So, I'm going to get an idea of what my sign should be. Plus and plus. Step 2. 3 times 10 equals 30. 1 and 30. 2 and 15. 3 and 10. 5 and 6. I need to pick the pair that combine to give me positive 17, which is in the middle. Step 3. This is going to be 17x equals 2x plus 15x. So now step 4. Okay, now, I will be honest with you. I realize in this last problem, we got brackets, we got parentheses, we got them all over the place. That is the way I like to do this, but then again, I have a lot of experience with this. If you don't want to write all that brackets and all that stuff. That's fine. My only suggestion is when you get to the end, you better make sure that you remember there's an X out front. Because if you forget, it'll mark the problem wrong. Okay? And what I'm saying is if you just wanted to do this, 3x squared plus 2x plus 15x plus 10. If you just wanted to leave it like that, just remember, at the very end, you got an X out front. Okay? All right? So we could factor by grouping. In the first set of parentheses, I can factor out an X. In the second set, I can factor out a 5. For my common binomial of 3x plus 2, and whatever left over, x plus 5, is the final result. So all I did here is I didn't write the GCF for step 4, so it was a little easier for me to focus. But normally, I would definitely have that X out front. But that's just me. That's how I roll. It was very popular back in my day. All right, are there any questions? All right, now here comes the fun part. I'm being honest with you. All right? We've done some very, very in-depth factoring, okay? The next section, I'm going to skip this problem. The next section here, we're going to come back to it. We'll come back to it, okay? Because this is a special type of factoring. I'm going to get through the easy part. So in section 5. Oh, I'm sorry. Let me go back. Are there any questions? I feel like I'm going 100 miles an hour. Are there any questions? I didn't ask that, and I'm sorry for that. I should have. All right. So I don't hear anybody. So I'm guessing that there are no questions. So now we're going to go into section 5. Okay? Now in section 5, it is all about formulas. That's all it is. So in the first objective, we're going to be factoring what we call difference of squares. Now, think about what the name says. Difference means you got to have a minus sign. Squares, both terms have to be squares. And how many? Well, there's only 2 terms. So, excuse me. If you wanted to, now, let me go back. In chapter 12, we learned about the sum and difference of binomials. In other words, we learned in chapter 12 that if you have the same exact terms in the binomials, the only thing that's different are the signs, then we didn't have to really distribute everything. All we had to do was say, oops, too far. All we said was, well, let's just multiply x times x, which is x squared, and then 5 times negative 5, which is negative 25. I mean, if you think about this, those middle terms will always drop out. Okay? I'm giving you the answer. I'm telling you, okay, here's the answer. It's x squared minus 25. You got to tell me what 2 binomials I multiplied to get that. Well, remember, we're going from right to left. This is like Jeopardy all over again. If you notice, and this is the key, if you notice in this big box where it says factoring the difference of 2 squares, if you have a minus sign in the middle, you have 2 terms, and both of those terms are perfect squares, it will always factor down into a plus b, a minus b. Let me show you how easy this is with the very first example. The very first example is x squared minus 81. I have 2 terms. I have a minus sign in between. X squared is a perfect square. The only question I need to ask myself is, what squared equals 81? And that's 9 squared. So this is going to equal x plus 9 and x minus 9. That's it. That is as hard as it gets. Look at number 2. You got x squared minus 64. You got 2 terms, a minus sign in between. The first term is a perfect square. The second one, 64. What squared equals 64? What squared equals 64? Okay, well, let's go through the list. 1 squared equals 1. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64, which is what I want. 9 squared equals 81. 10 squared equals 100. And I'll give you a couple more. 11 squared equals 121. 12 squared equals 144. 13 squared equals 169. And I think that's good enough. You never ever hear me say memorize numbers. I always say understand the technique. These numbers right here that I wrote, this little box, definitely memorize them. You should know what they are, because it's going to make your life easier. So, x squared minus 64, x plus 8, x minus 8. For number 3, how many terms? 2. Is there a minus sign in between? Yes. Is the first term a perfect square? Now, the first term is 9x squared. If you needed to, you can rewrite 9x squared as the quantity of 3x squared. Because remember, a power raised to a power, you multiply the powers. So, 3x squared is my first term. My second term is 1. And I know 1 squared equals 1. So that's a perfect square also. So this is going to be 3x plus 1 and 3x minus 1. I can't stress this enough. There is no math involved here. The work has already been done for you. We're giving you a formula. The only thing you need to be able to do is recognize, can I apply the formula or can I not apply the formula? Okay, that's it. Can I apply it or can I not? Look at number 4. 36a squared minus 49b squared. Listen how I'm asking myself the questions. How many terms? 2. Is there a minus sign? Yes. Like this is the process that goes off in my head. 1. How many terms? 2. Is there a minus sign? Yes. Here's 3. Are the terms perfect squares? Meaning, are the numbers inside this chart? And a perfect square is a number times itself. 5 times 5, 6 times 6, 7 times 7, 8 times 8. Here, we have 36 and we have 49, and they are on my chart. Yes. So, how does this factor? What number squared is 36? Well, that's going to be 6a squared plus what number squared is 49? Well, that's going to be 7. So, sorry, I put a square there. I shouldn't have. So this is going to be 6a plus 7b. 6a minus 7b. And that's it. It's all about the formula. It's all about the formula. Okay? Look at number 5. Quickly, somebody tell me what number 5 factors down into.
The quantity of, you want the full answer?
Yes.
P plus 5/6, P minus 5/6.
You are a factoring genius. That's correct. Some of us may have looked at that and went, oh, fractions. Oh no. Who cares? Is the fraction a perfect square? Yes. All right. I'm going to zoom out here a little bit. Number 6, I'm putting a star next to. Because number 6 is by far one of the math professor's favorite problems to put on a test. It's one of our favorite. Let me ask you a question. Does that look like we can factor by using difference of squares? I mean, let's be honest. Step 1, how many terms? 2. Step 2, is there a minus sign? Abso-freaking-lutely. Step 3, are those things perfect squares? The 81 is super easy to see. That's 9 times 9. The question is, what about the z to the 4th? Can somebody tell me what this answer is? Let's see if we could just guess it. This is our favorite problem to put on a test. Just take a guess. Here, I'll give you a hint. If you go all the way back, let me scroll all the way up real quick. If you go all the way back to here, remember, that thing has to be squared and that thing has to be squared. The easiest way to ask yourself that is by writing 2 sets of parentheses and then putting the number in that you need to square to get the thing up top. So in other words, 9 squared equals 81. What goes right here to give me z to the 4th? What do you think? Just take a guess. But you got to unmute yourself. Don't all speak at once. I only have 2 speakers.
Z squared.
I love it. Remember, a power raised to a power, you multiply them together. So z to the 2nd raised to the 2nd is exactly what we needed. April, why don't you tell me what the answer would be then?
Okay. Quantity of z squared minus 9 and z squared plus 9.
Perfect. Are we done? Can I put a box around this? Am I done? Am I done? It's a yes or a no. I told you this is our favorite problem, right? So, are we done?
Do you have to simplify it further? I feel like I don't see it say simplify, so I would probably say I'm done.
Okay, and then I would say, oh, but Courtney, you're wrong.
Because you always simplify.
There is another thing we can do here. What do you have right here?
The squares.
You got difference of squares again.
Yeah.
You have it again. You have 2 terms. They're both perfect squares with a minus in between. So that can be factored. Z plus 3, z minus 3 times z squared plus 9. Now, I know I'm done. Okay? You got to be careful with this. This is why it's the #1 problem that math people like myself will put on a quiz or a test because it really tests you. Do you know what you're looking at? Okay? Now, some of you may be asking yourself, well, Mr. Float, you factored the z squared minus 9 into z plus 3 and z minus 3. Why didn't you do that for the second part? Here's why. If you look at number 7, we have m squared plus 49. How many terms? 2. Is the sign in between a minus? No. You could stop. This is prime. You can't factor that. It doesn't work. You cannot factor that. And that's why I did not factor the z squared plus 9. Because of the plus sign in between. Yeah, plus sign ruined everything for me. Okay? Are there any questions? All right, well, I promised you a long time ago that I would give you a flow chart. And here's what it looks like. Okay, I'm going to upload it right after class because I'm pretty much done for today. All right, but I'm going to put it on the screen. So here is our factoring flow chart. So the first thing you're going to want to do is you're going to start off on the left-hand side here. So you're going to start off over here. Okay? Hopefully everyone's looking at the screen because it's kind of important. So, first thing you're going to do, factor the GCF out. You may have one, you may not. The second thing, polynomial type. Now, you have binomials, trinomials, and let me zoom out here just a little bit. And then a polynomial with 4 terms. Okay? That's the question, how many terms? If there's 2, it's a binomial. Now, if you have perfect squares, meaning x squared and let's say 9, which is x squared plus 3 and x squared minus 3. In other words, the variable will tell you if you have perfect squares because it's going to say x to the second. If you have perfect squares, okay, then what's the sign in between? If it's a difference of squares. There's your formula with an example. If it's a plus or a sum, it does not factor. It's prime. Now, if you have 2 squares, if you have 2 terms, and it's perfect cubes, meaning x to the third. We didn't do that yet, but here's the formulas. There's a formula for the difference of cubes, a cubed minus b cubed, that's the formula. And then there's a formula for the sum of cubes, a to the third plus b to the third. We're going to go over that on Monday. Okay? Trinomials. If a equals 1, then you can go right into this thing. You can go right into the 2 parentheses, put an x, figure out your signs. The f means factor 1 and factor 2. So if you think about it, 2 numbers that multiply, those are called factors, to give you the product of the third term, okay? If a does not equal 1, look what it says. Use AC method, factor by grouping, okay? And then the last polynomial type, if you just automatically start with 4 terms, boom, factor by grouping. I would print this up, or I would rewrite it exactly how it looks. Every single problem, I would start on the far left, factor out the GCF, and move your finger across that flow chart as you were doing your problem, so you get used to using this. Normally, I would print this up and I would say, you can use this on your test. I need you to take that initiative and print it up or write it yourself, okay? So I will upload it to Blackboard. I will. I'm going to do it right now, okay? But know how to use this. This helps you with everything. When I started teaching, I used to have students just memorize all this. And I would say, okay, here's your test. Good luck. And then what I found was it is just a crazy amount of information. So then here's what I noticed. Homework scores were really good. Exam scores were garbage. And I'm like, what's going on here? And then I thought to myself, it's you, it's not them. It's you, Floater. You got to change the way you do this. Something got to change. So then I thought to myself, all right, well, this is a lot of information. What if I gave them a flowchart? I'm not giving you the answers, but I'm giving you a flowchart. Maybe that'll help you kind of organize your thoughts. And then as soon as I gave this, scores started to come back up. Homework scores and exam scores matched. And what I also noticed was the exams themselves, the work that was shown was so much more detailed, organized, and I think it was because of this. So I'm going to stick with this for now. Until this breaks, then I'll figure something else out. Are we good? All right, so I'm going to stop the recording, stop the class,